Hello everybody. The next topic we're going to be looking at is classes and objects. Our main goals for this lecture is to learn about classes. In doing so, we're going to get a general overview of what classes are. We're going to be able to define and use classes after this lecture. We're going to have a basic understanding on how objects are constructed, and in doing so we're going to understand the relationship between classes and objects. We're going to learn how to define an array of objects and also to see how functions work with objects. So a lot of the material here are going to be building on what we've learned from before. So it's not really new material, it's just we're going to learn to see how everything works with objects now. So we're going to see things are quite similar to arrays. An important note here, so this is going to be a very simple overview of heterogeneous data structures. We talked about homogeneous data structures. Homogeneous data structures are arrays which allow for the grouping of data of the same type. With heterogeneous data types, such as classes, we're going to be able to define new types of variables, and we're going to be able to group different types of data together. I know that sounds a bit abstract, but it's going to become very clear throughout this lecture. It is important to note, however, that we are not going to be covering object-oriented programming. So object-oriented programming, or OOP, is a very advanced form of programming. It's what it is used in the industry. If you're continuing on learning programming, you're going to be exposed to it quite soon in the future courses. However, here we're just going to introduce what classes are, and we're going to use classes in our programs a little bit, but by no means we're doing object-oriented programming. Imagine if you are writing a program to store the information for a student. Student has a lot of information that needs storing. For example, they would have a name. You would probably store that in a string. Well, not probably, definitely. First name, again, in a string. An ID number is going to be an int. A midterm grade. Final grade. Perhaps that would be a float. Overall grade would be another float. And a letter grade, which would be a character, would be stored in a char. Now, if you wanted to store all this information in different variables, then that would be a very large program, a whole bunch of individual variables, and it would be very disorganized. So what could we do to organize our program and to be able to organize information for a single person? Well, the answer is we need to provide another data structure, another data container that is able to embody all this other data. So it's going to be a heterogeneous data container that is going to be capable of embodying a whole bunch of other data containers. So in essence, what it's going to be is that it's going to be a super variable. That's what it is. It's a variable that is going to embody and it's going to contain other variables inside of it. This allows grouping of data to be passed around in a single variable, because you have a whole bunch of variables inside of one variable. And this is going to be called abstraction of data, because you have a whole bunch of data inside of one data structure. So what is a class? A class is a template for a new data type. That means you can define your own data type in processing. So if you have a processing program, what are the data types that we know? Well, we have int. So you could say int x, for instance. We have double y. We have also char. We have float. These are all our data types. Well, using classes, you can define your own data type. What does that mean? So, for example, you could say class, and you could find a name for your class. So let's say class student. And this is your data type. This is your data type. So for example, you say a student is going to always have a name. And let's say you say student is going to have an ID. That's how you define a new student type. So that means in my processing program, let me just clean it up a little bit here. In my program, I have an int x. I'm actually going to draw the memory diagram here. So this is set up. I have x, inside of which is garbage. I have y, which occupies more of a memory, inside of which is garbage as well. And I have a new type. So what is in memory right now? Nothing is in memory because I haven't actually loaded anything up. I have just defined a new variable type. So this is a new variable type. What does it mean? It means that I can declare a variable of type student because it's a new type now, right? So I could say student, and I'm just gonna call it Z. So you see what's happening is student is a variable type and Z is a variable. You see? Student is a new variable type that I just defined up here, so I can use it just as I can use int x and and double y. And Z is just a variable name. So what happens in memory now? Z is created in memory, but it hasn't been constructed, right? It hasn't actually been constructed in memory. So it's an address, it's a dot in memory. It exists, but you haven't given it any place yet. So it's fine, being like that for the most part. Going back to the slides, I asked another question right after what is a class. So a class is a template for a new data type. That means when you define a class, you make a new data type. Then you can use that data type to create new variables. So I asked another question. I'm saying, what is an object? An object is basically a variable of type class. In object-oriented terminology, an object is an instance of a class. So going back to my example, can you spot the object here? If you said Z, you're right. So Z is the object. So Z is a variable of type student. So Z is an object. Z is an object because Z is a variable of type class. So anytime you have a variable of type class, that variable is called an object. So variable of type class is an object. Now, the way we have defined Z, it's just a dot in memory. It doesn't exist. In order to make it, because see, objects could have different types of memory. Objects are basically a variable that has variables inside. So an object could actually be referred to as a super variable, because an object is a box inside of which you have all these other variables, all these other boxes. So the object, in order for it to be created in memory, you have to construct it. That's the key word. You have to construct an object. So just like with the arrays, you ask for more memory. When you ask for, so dynamically you ask for more memory. And you guys remember how to do that. You would basically say new. So new is when you're asking for more memory. And in order to construct an object, you call the class name, which is student, with brackets. This is, and my drawing is getting a little bit too busy, but this is called a constructor. So the constructor is the name of the class followed by two brackets. And every time you see the parentheses after something, it means that it's some kind of a function. You guys know that, right? This is the constructor, and in fact, if I want to be really technically correct, it's actually called the default constructor. The default constructor constructs your object for you in memory. So here, you're declaring an object. Here, you're constructing the object. So this will construct it like this. Like I said, it's a box with two little boxes inside. You have a string and you have ID, which is initialized to 0, and string because we haven't put anything in it yet, right? So that's how it's going to work. So I'm just going to label my diagram one last time. So here we are declaring the object Z. Here, I'm out of room. We are, let's do like a little bubble here, constructing object Z. So we declare it and then we construct it. Very much like the arrays. We declare it and then we ask for memory. Here we actually need to construct the object. So now you should fully have understood the relationship between a class and object. So a class is the type that you define. Once you define the type, an object is a variable of type class.